Okay, now question number 41. In a permanent magnet moving coil instrument, the deflecting torque, which of this option is right? So, the deflecting torque equation of permanent magnet moving coil instrument is NBAI. NBAI. Now, NBAI, let me show you. Okay. Now, this is the deflecting torque equation of PMMC, NBAI, where N is the number of turns, B is the flux density or the magnetic field, A is your area of cross section, and I is the current. So from this equation we can see that this is directly proportional to number of turns, flux density or the magnetic field, the area of cross section, and the current in the coil. So our right option will be directly proportional to both the number of turns and flux density, directly proportional to the number of turns and inversely proportional to the flux density, inversely. So this one is the right answer, directly proportional to both the number of turns and the flux density. Next question. In a series RL circuit, voltage across resistor and inductor is 3 volt and 4 volt respectively. Then what is the applied voltage? So in order to find the applied voltage, we need to find the resultant of these two voltage, because we know that in case of inductor voltage leads the resistor voltage. মানে voltage across inductor leads the voltage across resistor, and the resultant voltage is what? The applied voltage. So here if we do the resultant of these two voltages, that is root over 3 square plus 4 square, we will get 5 volt as the answer, I guess. Yes, 5 volt. So the correct option here, it is B, 5 volt. Next question. A spring controlled moving iron voltmeter with full scale deflection of 150 volt draws a current of 2 milliampere. What will the meter reading be if it draws a current of 1 milliampere? Now, in case of moving iron, the deflection is proportional to current square. So, the equation will be 150 volt, this is the full scale deflection, 150 volt by the deflection to be measured when it draws a current of 1 milliampere is equal to 2 milliampere by 1 milliampere square. The equation will be like this: 150 by V is equal to 4 by 1 because this one is 2 and 2 square is 4. So the new voltage, new deflection or the voltage will be 37.5 volt. So the right option is 37.5. Okay, now two capacitance C1 is equal to 150 plus 2.4 microfarad and C2 is equal to 120 plus minus 15 microfarad. What is the limiting error of the resultant capacitance? This question is a bit incomplete. Here they haven't said that the capacitors are in parallel or in series. But with the following options, if we calculate, then we will get the capacitors are in series. And if it is in series, the limiting error will be 2.4 plus 1 point, this is 1.5. So it will be 3.9 microfarad. This will be the answer. But if these two are in parallel, then how to solve? If these two are in parallel, then we need to remember this equation, that is del r is the limiting error that we need to find. R square is the parallel equivalent capacitance or resistance that we will get by solving the absolute values 150, 120. So 1 by 50 plus 1 by 20, that will be 150 into 120 by 150 plus 120. We will get the value, absolute value r square, and del r1 is 2.4 by r1 square by 150 square, and del r2 is 1.5 by r2 square 120 whole square. So if we solve this by keeping del r in left hand side and taking this r square equivalent resistance of the absolute value to the right hand side, and after solving we will get the del r limiting error for parallel if the capacitances were in parallel. Next question, 45. For symmetrical waveform, average value of one full cycle is always 0 because it is symmetrical. Which of the following essential features is possessed by an indicating instrument? So this one is all of this. It will have a deflecting device, it will have a controlling device, it will have a damping device. Question number 47. What quantity of charge must be delivered by a battery with a potential difference of 110 volt to do 660 joule of work? Now for this, we need to find the C, the charge. So we have a formula, everybody must be knowing it, that Q is equal to CV, where Q is the work, C is the charge, and V is 110 volt. So C is equal to, the charge is equal to Q by V, which is 6 coulomb, the right answer, B. Now, question number 48. A 0 to 25 ampere ammeter has a guaranteed accuracy of 1% of full scale reading. The current measured by this ammeter is 10 ampere. The limiting error is in percentage for this instrument is. Okay, so to solve the limiting error in percentage, we have a formula. The accuracy, this one, 1%, 1% of full scale reading, 1% into our full scale reading, that is 25. Now this 1% is also known as GEA. This 1% into 25, the full scale reading 25 by the measured value 10. So what we will get, 1% into 25 by 10, we will get 2.5%. This is the limiting error percentage. Okay, question number 49. A thyroid type lightning arrestor, what it does, it offers a low resistance path to the surge appearing in the line. Always remember that an lightning arrestor, they offers a low resistance path so that current flows through this path easily. Question number 50. Where the voltages are high and current to be interrupted is low, the circuit breaker preferred is. For this condition, when the voltages are high and the current to be interrupted is low, we prefer vacuum circuit breaker. Moreover, you should remember this air blast circuit breaker and SF6 circuit breaker are used for high voltages, and oil circuit breakers, this is used for voltages below 33 kV, generally below 33 kV. Above 33 kV, we use this air blast circuit breaker and SF6 circuit breakers. Okay.